welcome to The Explainer. I am absolutely thrilled to have you here today because, well, we're tracking some massive structural shifts happening right now. This is our deep dive into the Shanghai Star 50 Weekly, and today we're focusing specifically on this explosive intersection of artificial intelligence, foundry capacity, and strategic capital. We're going to look at the data driving the ecosystem this week, and honestly, the numbers tell a fascinating story. It's the story of an industry racing to meet unprecedented demand, all while navigating some very real physical bottlenecks. So, whether you're an investor, a tech enthusiast, or just someone who relies on smart devices every single day, the ripple effects of what we're about to cover, they are eventually going to reach your pocket.
Okay, let's dive into this. 37%. That is the staggering year-to-date return of the Star 50 index. And to put that into perspective, this kind of growth isn't just your standard market fluctuation, right? It's a massive signal. It tells us that despite short-term profit-taking or overall market volatility, the long-term confidence in these deep technology and semiconductor entities is incredibly high. But to really understand why this number is so massive, we have to look under the hood at the macroeconomic environment that's actually driving this rally.
Section 1. Capital Shifts and Star 50.
So the story of this 37% return really begins with capital. Specifically, how state-backed capital is maneuvering within the market to optimize the entire semiconductor supply chain. On May 26th, we saw a highly strategic move. The National Integrated Circuit Industry Investment Fund, which most of us just know as the Big Fund, slightly reduced its long position in Semiconductor Manufacturing International Corporation, or SMIC. They stepped down from 8.08% to 7.99%. Now, at first glance, you might be wondering, wait, is the fund pulling back? But the data tells us absolutely not. This is a highly calculated maneuver.
See, by paring down its position in established giants like SMIC, the big fund is actually freeing up liquidity. It's a classic effort in capital recycling. They're targeting critical upstream bottlenecks now. We're talking semiconductor manufacturing equipment, electronic design automation software, and advanced packaging materials. This is all about securing domestic self-sufficiency. They're essentially moving money from the mature parts of the ecosystem to fortify the foundation. It's like reinforcing the basement of a skyscraper before you build the top floors.
Section 2. SMIC's Surging Foundry Dominance.
Now, while the big fund shifts its focus upstream, the foundries themselves are aggressively capitalizing on this ecosystem shift, and SMIC is sitting right at the very center of this. To really grasp SMIC's ambition right now, you just have to look at this figure, 40.6 billion RMB. For context, that's roughly the GDP of a small island nation. And SMIC is spending it just to finalize an acquisition for a 49% stake in SMIC North, which gives them full ownership. Why drop over 40 billion RMB? Because they are aggressively expanding their 12-inch wafer production. The demand for foundational chips, power management semiconductors, and localized IoT orders is surging, and SMIC is just straight up buying the capacity to meet it head-on.
And when we look at SMIC's gross margins, we can clearly see the financial impact of that capacity crunch. Back in the third quarter of 2025, capacity utilization hit a low point. But since then, utilization has nearly doubled. Because capacity is so tight right now, SMIC actually holds significant pricing power. They've been able to negotiate price hikes for supply-constrained product categories, which is exactly why their projected gross margins for the second quarter of 2026 are climbing all the way up to between 20 and 22%.
Section 3. AI Chip Revenue Explosion. Domestic Ambitions. Now we're going to shift our narrative from the physical manufacturing of the foundries to the explosive, almost limitless ambitions of domestic AI chip designers. Because this is really where all that demand is originating. And I want this number to really sink in for a second. 159.56%. That is the year-over-year revenue jump for Cambricon Technologies in the first quarter of 2026. This isn't just hype or, speculative forecasting. This is hard, realized revenue. The domestic AI computing chip market is rapidly transitioning away from just making technological breakthroughs to massive, scalable commercial deployment.
Now, what's really interesting here is the financial health behind that growth. Cambricon hit 2.885 billion RMB in revenue and pulled in a net profit of 1.013 billion RMB. But honestly, the most crucial takeaway here, something that isn't even fully captured just by looking at the profit numbers, is their operating cash flow. In Q1, it actually turned positive at 834 million RMB. That is literally the first time they've had positive quarterly operating cash flows since they listed. It proves their software platforms and AI application scenarios have successfully cleared that final hurdle of large-scale commercial validation. And hey, it's not just Cambricon. Look at Hygon Information Technology. Their revenue is projected to leap from 20.847 billion RMB this year to an astonishing 40.860 billion by 2028. That represents a massive compound annual growth rate of almost 40%. They are basically riding this incredible dual-engine strategy right now with their CPUs and their deep compute data center units, and they're capturing a huge swath of the AI server market in the process.
And this brilliantly illustrates exactly how the market is maturing. Shen Xiaoquan, the general manager over at Hygon, points out that we are finally moving past the phase of simply throwing hardware at the wall to see what sticks. The competition is no longer just about who can build the absolute biggest cluster. It's now about energy efficiency, cluster utilization, and total lifecycle costs. As the AI hardware market matures, buyers are demanding real, sustainable performance, not just raw theoretical specifications.
A perfect example of that kind of performance happened recently when the massive open-source model DeepSeek V4 was released, which featured a 1 million token context length and ultra-low inference costs. The domestic firms, they were ready immediately. Hygon's Deep Compute 3, Cambricon's C1 series, and more threads with their MTT S5000 all achieved day zero adaptation. They provided turnkey, ready-to-deploy domestic solutions on the exact day the model launched. They completely closed the loop from software release straight to hardware execution.
Section 4. Bypassing bottlenecks. Advanced nodes.
But of course, every great growth story has an antagonist, right? And ours is the clash between soaring AI design ambitions and very real, stubborn physical manufacturing limitations. On one side of the scale, we've got Cambricon, which is rumored to be aiming to triple the output of its AI chips in 2026 just to capture surging demand. But on the other side, we have SMIC's N+2 process capacity. The N+2 node is currently the most advanced and stable domestic process available, but its capacity is strictly limited. So there's this massive bottleneck forming where the software demand is far outpacing the actual physical silicon supply.
Now you may be wondering, well, why not just move to the next generation of nodes? Well, take a look at this figure, 20%. Imagine baking a huge batch of cookies, right? But the recipe is so impossibly complex that you literally have to throw 8 out of every 10 cookies straight into the trash. That's essentially what's happening here. Industry estimates suggest that the yield for SMIC's next generation N+3 and N+4 processes currently hovers around just 20%. This is because they rely heavily on highly complex multiple patterning steps. So until there's a major breakthrough in advanced lithography, scaling up these cutting-edge nodes efficiently is going to remain a very significant hurdle.
So how is the ecosystem adapting to this? Well, companies are getting highly creative with workarounds. VeriSilicon, for example, is stepping up by offering custom ASIC IPs that actually allow AI developers to hyper-optimize their designs so they can run on older, mature, and highly stable nodes. Meanwhile, companies like Amlogic are absolutely thriving by scooping up the consumer and IoT edge computing orders that the big global fabs are kind of neglecting right now as they chase those advanced AI nodes. They are proving that you really don't always need the smallest nanometer process to capture massive market value.
Section 5. Global expansions and legal fights. As these Star 50 giants mature, their ambitions are stretching far beyond domestic borders, which brings a whole new set of opportunities and challenges on the global stage. Take Shanghai United Imaging Healthcare, for example. They recently showcased their ultra-advanced AI-powered PET/CT and PET/MR systems at a major medical conference right in Los Angeles. This aggressive North American expansion is a crystal-clear indicator of the global ambitions of China's medical and biotech sectors. I mean, they aren't just competing on price anymore. They are competing at the absolute cutting edge of AI-driven medical diagnostics.
But as we know, global expansion also brings global legal battles. We are currently watching a highly complex fight unfold at the Unified Patent Court between Ericsson and Shenzhen Transition over 5G patents. Transition is currently dealing with injunctions and disputes over what are called FRAND-specific claims, which stands for Fair, Reasonable, and Non-Discriminatory Licensing Rates. It just goes to show that as these Star 50 companies push into international markets, mastering these complex global intellectual property frontiers is becoming just as critical to their survival as mastering their own engineering.
Which brings us to the ultimate question we really have to ask ourselves after looking at all this data. As state capital recycles to build up the supply chain and software AI demand absolutely explodes, can the domestic foundries actually scale fast enough to support this next generation of computing? The ingenuity is clearly there. I mean, we saw the clever workarounds and those incredible day zero adaptations, but the physical manufacturing limits are going to be the ultimate test of this ecosystem's resilience. It is just a fascinating space to watch right now. Thank you so much for joining me for this explainer, and I highly encourage you to keep tracking these incredible developments with us.